let's talk about DFW. We're talking about deployments. We're talking about autonomy. Great proof of concept happening out there in the Dallas-Fort Worth area. You're very much involved in that. Everybody's talking about operational evaluations and what's going on down there. I know you did some things through NASA and a DOT Smart Grant initiative. Tell us about those things.
Well, first, I want to address something you said earlier. You know, the FAA in their NPRMS, in the preamble, acknowledged that weather between METAR sites is uncertain, basically, that you can't depend on the data from a METAR site once you get away from the airport. They use 5 nautical miles as a rule of thumb. We generally do that. But the issue is that changes based on the weather. The worse the weather is, the smaller the relevancy of that area. That's the challenge, because the weather changes, right, locally. So they've acknowledged that, and they've said that we are going to have to look at using third-party weather services as part of the system, potentially, to solve this. And they've written Part 146 as draft, and they have something called an automated data service provider. And weather used to be a supplemental data service provider, but due to banging on the drum from people you know on this call, they now recognize we need to bring it up to the same level as detect and avoid and surveillance, and they have. And so we're working right now on an NTAP waiver with the FAA. I give them a lot of credit. Meetings out of this morning indicate that around Dallas-Fort Worth, we're going to hopefully have that, and it's going to be maybe even adaptable to more operators than just one at a time based on what we discussed this morning. I give them a lot of credit. We have the best weather network really in the world right now around Fort Worth to do this testing and evaluation, not just of trying to demonstrate the value of this data to end users if they're willing to try it, but also the value of the standard that we've written for ASTM, the value of what FAA is trying to do with Part 146, and the value of how this is all coming together so that third-party weather providers can be trusted and used for UTM and for sharing data across the ecosystem, and they can do it safely. So that's the big point about the Dallas-Fort Worth area. And I think what you're seeing is
a cool video, Don. So what I want to do, let's roll the video and you talk over this and tell us what we're seeing. Let's go ahead and roll that.
So this was the beginning of us putting our first scanning wind LiDAR in the Dallas-Fort Worth area. The video you see is the helicopter dropping that on top of Alliance Airport's terminal. Thank you, Chris Ash. Thank you, North Texas. Thank you, Ernest Huffman. Thank you, everybody who's believed that we got a problem here. We've got to start getting our head around. And what this is these scanning wind LiDARs, there's 3 of them. And there's also vertical LiDAR. So a scanning wind LiDAR could see 5 to 10 kilometers on a radius. And we do searches for wind using Doppler technology and looking for dirt and dust in the air. And we can then take that data and we can bring it into a grid, and we can have much more accurate low altitude weather at different layers up to about 3,000 feet. We also have vertical wind LiDARs we're putting out, which are just pointing straight up. And then we also have ceilometers to collect ceiling height between airports and visibility sensors and cameras. So we're going to have a much better picture of what the low altitude looks like from a micro weather perspective. And then we're going to start running our modeling. And I think we're going to show that in a second, some of the wind modeling that we are demonstrating today and running every hour around Fort Worth.
Here we go. Here's that video. We're rolling right into it. Tell us what we're looking at.
So what this is this is a 2 by 2 kilometer area. We call this swaps. And what it does is it takes the current model that we think is the best available data. We downscale that and run it through the buildings. And what this shows you is how buildings change the wind speed and direction. And so we're going to be working to get this packaged into a product that we could give to our operators through some of our partners out there today we're working with to get this to them so they could do a better, manage their routes better, stay away from where the winds are swirling around buildings too much, because winds actually blow downwind off these buildings. So, you may want to change your route to go upwind of a building on a certain day. This shows you what those winds are looking like and how they're swirling. This is going to be very critical at vertiports in urban areas, right? Because, right now it's kind of a guess about what those winds are looking like. You got a windsock, really, and you know, and a windsock is good to 15 knots, and you have to be looking at it. So it's not very good for digitizing information to get it into automated systems. So what we want to do is get this out. We also going to be assimilating that LiDAR data in. So we're going to get better conditions of what's really happening. And then we'll be able to do machine learning and validation of this. And we'll be able to improve these forecasts over a period of time, over a year or two. And that's what real machine learning about weather's about, having real data and validating it with real data in order to improve the forecast. And so I'm looking forward to getting this out in other areas around the country, in certain areas, and as well as overseas.
I love it. I love that one of the key colors is pink. I just gotta give a shout out to that. And reminding me of pink, we've got Drone Desi Diva out there. Drone Diva Desi, I'm sorry, Desi Eckstein is out there as well. Love Desi and everything she's doing for the industry, and being a fan today, like saying, yes, Don, everything you're saying is so true. So
by the
awesome.
way, I just want to say that was live. So we're running that every hour today in that area as a demonstration.
Wow. Yeah.
It goes out to 6 hours. It takes into account the changing big weather changes, and then it downscales that into little changes that reverberate. And so we still got a lot of work to do. It's not productized yet, but that's what we're working on for 2026.